All right, everyone. Dr. Yang back here again, and this time we are going to talk about research designs. And I know what you're thinking. We are not doing research, we are doing program evaluation, and you are absolutely right. But sometimes when we start to think about how we might go about capturing the data that we need to capture, we have to put our research hats back on and think about, are we doing an experimental design? Are we doing a quasi-experimental design? Are we doing a single systems or a time series? How are we going to design our program evaluation to capture the data that we need to capture? So we're going to go back and revisit some of the content that you learned in Research 1 to think about how we can use that to inform the process and the design that we might use in the program evaluation, that step where we talk about evaluation and design. So remember back, we talked about the difference between an experimental and a quasi-experimental design. And most people are okay with an experimental design, but when you talk about a quasi-experimental, people get a little squirrely. So here's a little decision tree that helps us sort of orient ourselves to what type of design we're talking about. So the first thing you have to decide up here is random assignment happening? And remember, random assignment means that everybody in the population has an equal likelihood of being selected to participate in the intervention, okay? If you are handpicking people for any reason, it is no longer random. So if random assignment is happening, right? So yes, it is happening. Now we are talking about an experimental design in which we are likely doing a randomized control trial where we are randomizing people into the experimental condition to test whether or not we are able to prove that the successes or failures of that intervention can be attributed to our intervention. If there is no random assignment, the next thing we have to figure out is there a comparison group? Okay, and so a comparison group might be a group of people who are not getting the intervention. Could be people who are waitlisted to receive a program, or it could be folks who are getting the treatment as usual, but not the novel intervention of your program, any of those things. If there's a comparison group, then now, yes, we are talking about a quasi-experimental design. If not, we're talking about a non-experimental design. So most of you will be down here in one of these two groups. You will either have a comparison group, people who are waitlisted, things like that, or there will be no comparison group and no randomization. And that's okay, right? Remember, the purpose of this is not knowledge for the sake of knowledge. The purpose of this is to understand and evaluate the program. But by doing this, it helps us to understand sort of what we're talking about and to borrow from some of these ideas to help us design questions and sampling and other sorts of strategies. So for folks who are not the greatest at decision trees, here is another visualization of a common experimental design. This one up here is more of what we would see in a randomized controlled trial, okay? So you have randomization in a pre-test, an intervention, and a post-test, randomization, pre-test, no intervention, and post-test. So this would be like folks who, everyone gets a shot, but only these groups are getting the COVID vaccine. And we are testing the efficacy of the vaccine using that randomized controlled trial. This is likely not what you will be doing in your program evaluation. We could also do a post-test only comparison. So we randomize a bunch of people, we don't take a pre-test, we do a post-test, and then we look at we do an intervention, and then we look at the outcome. Okay. Again, this is mostly refreshing you, and these are not things that you will likely be expected to do in your program evaluation. The good thing about it in an experimental design, such as this one, which is the same thing we saw on the other side, is it helps us to address threats to internal validity. Sometimes with very large programs that are well-funded, we will see a randomized controlled design because it helps us to address the 3 criteria for causality, which are temporal precedence, okay? Was there a problem that was then fixed by an intervention? Correlation between the intervention and the outcome, and that we have ruled out alternative hypotheses. That is the benefit to a randomized control trial, in that we are much more able to assert those 3 criteria. temporal precedence, correlation, and alternative hypotheses. But randomization isn't always the bomb, okay? Sometimes there are ethical problems. We can't randomize people into certain problems, okay? We can't take a bunch of babies at a hospital and say, okay, these babies are going to be sent to homes that are neglectful, and these babies are going to be sent to good. Like, we can't do that. We can't go like walking down the street and say, hello, person, here's a bunch of opioids. I want you to continue to use these until you develop an addiction, and then we're going to randomize you into a treatment protocol. We can't do that. There's also practical challenges, most notably that they are expensive. But also, sometimes things are out of our control. Like, we can't control everything that a person does. We can't control the extraneous variables and things like that. So we need to look at a non-equivalent comparison group design. Now, this may be something that would fit for your program evaluation if you have two groups that you can compare. For example, folks on a wait list, right? So if you were trying to see how well a program can meet its goals, and you've got the group of people who are in this first category, meaning they're getting treatment, and then you've got this group of people who's on a wait list because maybe there's only a certain number of services you can provide. You can compare outcomes from this group to see if people are getting better spontaneously or if they're getting better because of your program. This may be a way for you to gain information about the efficacy of your program. If there's possibility to include more data points, you can do that. That increases the rigor of a quasi-experimental design. As we see here, we have 3 pre-tests, an intervention, and a post-test. What this tells us is, are people getting better spontaneously prior to the administration of our program? We can also switch replications, right? So maybe these are folks who are getting the program right now, and these are folks who are on a wait list. Then they graduate our program, and then these folks move off of a wait list. So these are some ways that we could use a quasi-experimental design to assess the success of our program. Okay, are people getting better? Is less child abuse happening? Are people discontinuing their use of substances? Things like that would all be possibly things that could be evaluated using a quasi-experimental design. However, many of you will not be using experimental methods to assess your program. So you will be doing surveys, you'll be doing cross-sectional point in time data collection. Remember, we're not going to do this for real, we're just proposing. And so this may not work. You may also want to propose an interrupted time series design. This also works well with single systems design, in that we are gathering frequent data points and we are marking an intervention and a baseline phase. But this would work if you had access to individual client data over time. This is a very strong quasi-experimental design, but again, many of you may not even have enough data or enough reason to use quasi-experimental methodology. You might only be looking at a single system design or something like a non-experimental survey design. So again, this is just a refresher of things that we have already learned to help us understand how we're going to wrap our brains around how we are going to assess the efficacy of our program. Thanks for your time. See you soon. Bye.